Okay, sign your attendance. All right, so we continue. Last week we stopped at 3.5, and what is important is this diagram. We have covered gases in chapter 2. Now in chapter 3 we cover liquid and solid, right? So previous lecture we cover also from gases to liquid, we go through condensation. From liquid to gases, it evaporates. There's some constant value that you need to be aware of, and there's some conversion to refer to the table. And also from liquid to solid, you will involve melting and freezing depending on the direction. And one extreme case is from solid directly into gases. You will go through simulation, which is like the dry ice. And some cases from gases directly to solid will be go through deposition, right? So we have done this in the previous lecture. Okay. They will look into forces, which is important in your test. So we will look into intermolecular forces, right? So last lecture, we look at chapter 3, look at two things. Intermolecular forces and thermal energy. Thermal energy. So last week we looked at delta H, look at thermal intermolecular forces. We look at three types of forces in this session. We look at dispersion, or in your SPM or maybe chemistry 1, you learn about London forces. We will revisit again. Then we look at dipole, hydrogen bonding, and ion dipole. So again, this chapter is important for your test and also final exam. So there will be one question come out from this section. All right. So this diagram is just show you the state of that particular substance. And again, in chapter 3, what is different from the previous chapter is it will be enclosed. So the container in chapter 3, it will be closed. So from here, you can transform from solid to liquid to gases and reverse the process. So the strength of intermolecular forces will decide the form or the state of the substance. Okay, so that is important. So the strength, now we look at the strength of intermolecular forces. So there are four forces: dispersion, dipole, hydrogen bonding, and ion dipole. So we look into these four types. Yeah. So if we compare to gases, liquid and solid, they have a strong intermolecular forces, right? That give high melting and boiling points compared to gases form. All right. So if you describe intermolecular forces as weak, it will automatically fall into gaseous state. So when you answer for your test or final exam, don't simply use weak intermolecular forces as your answer. If you reason, you ask in sections C in the question, it asks you why or the form of the element. Don't simply use weak intermolecular force. If you link weak intermolecular forces to liquid and solid, then it might be a wrong, incorrect answer, right? So if you mention about liquid and solid, and you need to use the intermolecular forces, then it will be four of these forces. It's either dispersion, dipole, hydrogen bonding, and ionic bonding. Okay? And this one is covalent bonding. It's under covalent bonding. Ionic bonding we already covered in chapter 1. So now we look at covalent bonding. All right. So this is just a highlight. When you study chapter 3, when it comes to intermolecular forces. So we look at 4 fundamental, which I mentioned just now. So increasing strength, they are this one is in the increasing order. The weakest one is dispersion force or London forces. Dispersion, then go to dipole, then go to hydrogen bond and ion dipole forces. So in this sequence. So from here, you can actually predict the melting point of that particular intermolecular forces, right? So elements that have ion dipole forces will have higher melting point compared to dispersion forces. Okay, so that particular element cannot exist with 4 types. It can only fall into only one of these forces only. Okay, so in the test, we might give you 4 elements, and then you through some calculation later, you decide whether they are dispersion force, they are dipole, or they are hydrogen bonding, or they are ion dipole. Then you rearrange the sequence according to the melting point. Okay, so this is the one that we'll try to assess your understanding in intermolecular forces. Yeah. Okay, so we go into dispersion forces. So in SPM level, you might heard London forces. So this in foundation in science, we will use dispersion force as a London forces. Of course, in exam, if you use London forces, I will accept also the correct answer for dispersion forces. Okay. Right. Okay, dispersion forces or London forces, they are looked at electron distribution. Okay, this electron distribution. So when we talk about distribution of the electron, then there is a positive side and negative side. So for example, if you look at the diagram, the one on the far left, you see a lot of dot here. If the side have lots of electron, then that will be a negative side. And you see the delta sign. Delta sign means partial differential, means a small differences of charges. So you see delta negative means that side it have a lot of electron in that side. So if more electron on the right hand side, then another side of the molecule will become positive side. Now we look at intermolecular force. So means if there's an imbalance of electron, then there will be a positive side and negative side. So in your, if this question come out, you need to tell me where is your negative side, where is your positive side. You need to put in delta negative or delta positive. When we talk about these 4 forces, you need to put in delta negative or delta positive in your diagram. Okay. So the first type, if you see on the left, is called unsymmetrical or asymmetrical, means unbalanced. Symmetrical means balanced, but if you add the asymmetrical means unbalanced. So here, unbalanced means density means you have a positive, not positive side. So yeah. Okay. What else? So these are the example. Then if you talk about symmetrical in the middle diagram, symmetrical electron density, then you see the distribution is quite balanced. Then another one is also another type of unsymmetrical. It's just that it's another orientation. On the left is called ideal case means it was oriented to left and right only. But if you see the one on the far right diagram, this one is a little bit directional. So positive on this side, negative on another side at a certain angle. Okay, so here, if you talk about, if you have a molecule, I write something on the whiteboard. If you have delta positive and delta negative, just remember you see this one as magnet effect. Negative will repel. positive will repel. So how these forces was generated when you have a positive and negative combined together, right? Like a magnet. So like this one, like I draw something on the whiteboard. To have the dispersion force to be created, your positive side must combine with another negative side of another element. Then you call dispersion force. It's because of the positive and negative partial differential of the electron density because of positive negatives. Okay. All right. Okay. So this dispersion force, the main keyword is your electron distribution. Electron distribution. Okay. So this one you read. All right. So here we have a helium, and you know that this orange color dot is electron. You know that electron can move any place that they want to go, but it's in the orbit form. Yeah. Okay. So this is a helium. So here you know that it is asymmetrical arranged now around the nucleus. In the middle one, it might seem it is symmetrical, but it's not. Why? If you draw a straight line, one of the two orange color dot here is not aligned in a straight line. It was somehow rotated maybe 5 degree or 10 degree. So this is called asymmetrical. So when you have an asymmetrical or distribution of electron, then you will have a positive side and negative side of the atom. Okay. 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 So as you can see on the frame number 3, which is the third example, if we have two electrons close to one side, then that side will be partial differential negative. That side will become negative pole. We call it negative pole, negative side. Okay. So delta means slightly, or in mathematic form, it's called partial, means a little bit changes of charges. Okay, so there's one word is called instantaneous. Instantaneous dipole means it just happened in maybe 1 second or 2 seconds in that particular time. Instantaneous. All right. And for the instantaneous dipole, especially for helium, it's the one that you see here. So the arrangement of the pole, positive, negative, it must be positive linked to negative side. Yeah. So if you negative, then it will repel. Repel means it break away the bonding, then it will change form already. Either from solid, it will change to liquid, and so on. Yeah. Okay. So dispersion force, the keyword is attract one another. It attract, it attract one another. How it attract? By combining the positive and negative instantaneous dipole. Okay. So dispersion force, we talk about instantaneous dipole. So it is a delta positive and delta negative of the atoms. And dispersion force is the weakest intermolecular forces among the four. Among the four. Okay. All right. So this is another illustration. So if you do not label anything on your atoms, it is called non-polar atom, means it's balanced. Right? means the distribution of electron is balanced for the atoms. In your answer, if you want to mention it is an instantaneous dipole, then you should label your atom with delta, positive or negative. Okay. Then you want to illustrate there's a dispersion force. You just use a dash line to connect two atoms or three atoms together. Okay. This is how you draw your answer. Okay, how you draw your answer. Okay, magnitude of the dispersion force is like a magnet. The more easier you attract each other, then it will be magnitude higher lah. Like a magnet lah, huh? Okay. All right. Now this one, dispersion force, depending on the size of electron cloud. Size of electron cloud, you can refer to the periodic table. Again, back to the basic of periodic table. I draw something on the whiteboard. So you know that the column here is group. Column here is group, which is the external electron outside. How many number of electron outside, right? This column, in the column, this column. However, the row is the size of the orbit. If you read from periodic table, the row, the row from a periodic table is the orbit, number of orbit you have. So the lower you go, the more orbit you have. Okay. Now, by combining the understanding of periodic table and this statement on these slides, this slide mentioned the magnitude of dispersion force depending on the size of electron cloud. So if the question asks you to use periodic table to compare element of their dispersion force, those that below the periodic table will have higher dispersion force compared to the one on the top. This is how you answer the question. Okay, right. This is just an illustration, the distribution of that one. Okay. A larger electron cloud, or you can say as an orbit, in a greater dispersion force because electrons are held less tightly by the nucleus and therefore can polarize easily. Because if you have bigger and bigger orbit, the central magnet or the central nucleus unable to pull the electron. So when you're unable to pull, or you can say unable to control the electron that is moving around the cloud, then you can easily combine the two atoms, right? Like a magnet, right? So the word here is polarized. The word for intermolecular is polarized, polar, because polar. Polarized. Polarized means appearing of distribution of electron in the cloud. Polarized. Okay. If other variable constant remain constant, dispersion force increase with increasing molar mass. What is molar mass? Molar mass is you combine the weight of the atoms for that particular molecule. Yeah. So dispersion force is increasing with molar mass. For example, H2O, the molar mass is 2 plus 16, you get 18 gram per mole. O2, you have O2 is 16 gram per mole. So dispersion force, if you compare hydrogen and oxygen, water H2O will have a higher dispersion force compared to oxygen. If we only look at molar mass. Yeah. So again, this chapter is important for your test and final exam. There will be one question ask you about this. I'm showing something on the whiteboard. Important, this one. I cannot give you tips already. What I'm going to ask you. There will be one question ask you about this. Okay. So this just to show you example: helium, Ne, argon, Kr, Xe. This one you can find in the periodic table 4 to 20.18 and so on. Yeah. Boiling point, as you can see here, the higher the molar mass, the boiling point is increased. So for example, He is 4.2 Kelvin. In this module, you need to use Kelvin and not Celsius. Yeah, Kelvin. And then as you go down, Xe is 160 Kelvin, still negative Celsius. Right. The molar mass alone does not determine the magnitude of the dispersion force, but it is useful for comparing dispersion force within a family of similar element of compound. So later we'll look at family of compound. Yeah. All right. So molar mass is for comparison, only to compare one to another in the same family. Right. Right. Again, why boiling point increase? Because there's a force, pulling force, to maintain the shape or the state of that particular element. All right. Now, I give the example on the whiteboard here and also on the slide here. Cl2 and I2, which one have a higher point and why? So this question actually basically asks you about the molar mass. You need to answer using molar mass. You need to write the statement. This statement, if all other variables are constant, this dispersion force increase with increasing molar mass. You need to write this statement to answer that particular question. It's important. This statement is important. Then you calculate the molar mass. Right? So this one is just a very fast. If you look at periodic table, you find Cl 35.45. Yeah. Right, 35, or this one is only give you two significant figure, two meaningful number. But the one that will be used in your test or final exam will have two decimal place. Okay. Iodine is 126. Iodine is here. It's about on the periodic table on this slide is 127. By comparing the molar mass, which one have higher boiling point? Which one? If you only compare molar mass, which one have higher? Iodine. Who cannot understand why iodine? Can right? So the step argument is this one. You need to write because element A have a higher molar mass, have a stronger dispersion compared to element B. The keyword we are looking for is, your argument is higher molar mass. Which one have higher? You need to prove with the number in your answer. Yeah. In test, you say a statement, then verify or justify with a number. Why? Okay. You say so, then why? Give me a number based on your calculation or based on periodic table and so on. This is how you answer question for chemistry 2. You give a statement or theory, based on theory what and what, and then based on calculation, there's a number, and that's why you see the phenomena, or that's why you see something happen. Yeah? Right. Okay, so if you understand this one, we can go to the next one. Yeah? Right. So again, this is another example. If you understand the previous tutorial question, the next question will ask you about hydrocarbon. Referring to periodic table, calculate the molar mass and use the statement to answer. Eh? So from here, basically you can tell which one have the higher boiling point already. Right? So C, carbon is 12, hydrogen is 1. So 12 plus 4 is 16. C2H6, carbon have two carbons, which is already 24. So from here, you know, by mental calculation, you know that C2H2 have higher boiling point. Argument is based on molar mass. Yeah, okay. Next, we go into dipole already. Yeah? Already done with dispersion force. Again, dispersion force is because of the polarized or polar imbalance of electron distribution that give you polar or polar positive or negative. Then it must be positive combined to negative side to form forces. And to compare relatively comparison, you use molar mass. Assumption is all the parameters are same, right? That one you need to mention. Now we go into dipole force. Dipole means, again, you need to, okay. So dipole axis is all polar molecules. Polar molecule have permanent dipole. Just now, the dispersion forces do not have permanent dipole. They have instantaneous dipole. Just now, the dispersion or London force, they have instantaneous dipole. But dipole, they have permanent dipole that interact with the permanent dipole of the neighboring bonding. Permanent dipole is the one that you learn in chapter 1 or chapter 2 that you convert 2 dots to a line. That is dipole. Okay? Or basically we call it covalent bonding. Okay? But here, because we talk about intermolecular forces, if the question you see intermolecular forces, don't use covalent bond. If you see the question asks you about type of, or you see intermolecular forces, you need to use either these four to answer. Dispersion, dipole, hydrogen bonding, or ion dipole. Okay, so how do we know it is the dipole? Basically, you can draw the dot of Levi's model that give you double bond, single bond, triple bond. Okay. All right. So here later, like for example, the ones you see on the diagram here is CH2O, which is give you the there's an imbalance of polar here, right? Okay. So the positive end of one permanent dipole are attract to negative end of another one. This attraction is called dipole forces. This statement is important if the question asks you dipole forces, or you need to prove that that element have a dipole forces. This statement is important. You need to write what is dipole-dipole force. Dipole-dipole force is when there is a positive one end of the permanent dipole attract to another negative end of another, right? So something like that. So you need to mention permanent dipole and then positive end combine or attract to negative. The word here, we keep using the word attract. Attract. So like the one you see on the diagram here, the positive dipole or polar, we call it polar, positive polar side will attract to negative polar side. But this one is permanent dipole. It's permanent. It's not instantaneous. If instantaneous, then it fall into London forces or dispersion forces. Okay. All right. So this is another one comparing the boiling point. So polar molecule have higher boiling point compared to the non-polar molecules. Non-polar means it's balanced. There's no positive delta positive or delta negative positive on the molecule. Okay, it's just a note, right? Remember, all molecules, they have dispersion force. In addition, polar molecules have dipole-dipole forces. This additional attraction force raise their melting point and boiling point relative to the non-polar molecule of a similar molar mass. If we have two elements have a same molar mass, then you look at the intermolecular forces. So you can start to imagine what kind of question will come out. You're given maybe 4 elements of the same molar mass, and then it will ask you arrange the element based on their melting temperature. Okay. Means the first one you already know. Oh, how do you compare melting point? Is through molar mass. So first step you do in your test, you will calculate the molar mass one. So molar mass you calculate, then you find actually 4 or 5 of these elements have the same gram per mole. Then you work to the next step, which is you need to identify whether they are polar molecule or not. They are polar or non-polar, for example. Okay, so example of these two. So you have C2H2 and C2H6 if you draw the structures. So we already know, assume you already know how to draw the Levi structures that you see on here that we cover in chapter 1 and chapter 2, maybe chapter 1, right? So from here, you know that the top one, CH2O, if you look at the structure, you know that it is sure have imbalance one because the structure, right? So this one you see is very symmetry one, very symmetry, so the charges will be balanced. So if you look at the shape like triangular, a T shape, that is imbalance. So imbalance of polar. So there will be a positive negative side. So if you see something like C2H6 is balanced, it's symmetry. If you cut in the middle, you see it's actually same. Right? So from here, this slide, it tells you the C2H2 is a polar. So it will have a higher melting point compared to the ethane. So it is C2H6. If you calculate the molar mass, two will be the same, 30 gram per mole, almost there. So in the test or final exam, you will see 4 or 5 elements that have the same molar mass. Then you need to argue your answer. Why one element have a higher boiling point to another based on the polarity, the polar of the one element is polar, one element is non-polar, and so on. You need to argue based on their polarity. Yeah. So we are now in the dipole forces. So again, these two elements you see can convert 2 dot with the line or 4 dot with a double line. The only difference here is because of their polar. So one is polar, one is non-polar. You know, for dipole, you have okay, dipole. Dipole. You have a polar molecule and non-polar molecule. And polar molecule have a higher melting point compared to non-polar. Okay. Another technical word for chemistry is called miscibility. Miscibility, if you have a polarity, a molecule have a polarity, then the liquid is able to mix together. All right. So for example, miscibility substance that fully mix, like if for example you mix alcohol and water, they're able to mix. Right. So if you mix oil and water, then it's immiscible, or the miscibility is very low. Okay. So miscibility, okay. In general, if the question asks you about miscibility of that two particular element, right? Element A plus element B. So you ask you whether they are able to describe the miscibility. So this answer, for example, polar and polar, they're able to mix together. Polar and polar element or molecule, they're able to mix. So polar liquid are miscible to another polar liquid, but not miscible with non-polar liquid. Polar means what? They have a positive, delta positive and delta negative. So they must have delta positive negative to combine together. Then only they can mix. If they don't have any positive negative, they cannot mix. That is the behind the theory. Okay. So water is polar in general common sense. When you take chemistry 2, the question will no longer mention this statement. We assume you know water is a polar liquid. Water is a polar liquid. We assume you automatically know already. Water is a polar when it cannot mix if you mix with non-polar liquid. For example, C5H12, which is the balance. If you draw the structures, it will be balanced. So when you balance, then non-polar. Non-polar cannot mix with polar. Non-polar, of course, cannot mix with non-polar. Yeah. Okay. So this is another example. Pentane cannot mix with water and so on. Okay. Oil and vinegar cannot mix because of polarity. Okay. So the question might ask you, what is your expected observation if you mix element A and element B and you're given maybe a density? Or maybe density is the same. So for example, I give you oil and vinegar. Of course, they will give you some molecular formula and ask you, when you mix these two together, what is your observation? So expected answer is they are unable to mix. So they will have a separate layer between the two elements. Something like that, right? So the answer we expected is you need to mention there's a separate layers. Okay. Yeah, this one is some accident, oil accident that you can see the oil split on the surface of sea and so on. Okay, so now this is just an exercise from chapter 1. They ask you to determine whether the molecule have dipole-dipole forces, right? So for example, CO2, CO2, so if it have a dipole-dipole forces, if it is a polar, so how do we know it is a polar? You draw Levi structures, right? So first, determine whether the molecule contain polar bonds. Second step, determine whether the polar bonds add together to form a net dipole, means the orientation of the structures. Okay, so for example, CO2, if you draw the Levi structures, it will in this form, O double line, C double line O, still in the straight line. So straight line in the linear form, if you cut in the middle, you will see there's a balance between the left and right. It is called non-polar. If you see balance, it is a non-polar. Again, non-polar cannot mix with any polar element. Okay. Do it have dipole-dipole force or not? Yes, because you can convert the double dot of the Levi's into lines. Okay. So here, CO2, you have a double bond. Double bond is a dipole-dipole force. Yeah. So there are two descriptions in the answer. If this one come out, you need to give me the Levi structures, and then you need to give me two characteristics of the material, which you need to mention whether it's polar or not. If it's polar, you mention polar. If it's non-polar, like for example, CO2 is non-polar, then you need to mention whether there is a dipole-dipole force or not. So here you don't have dipole-dipole force. Okay. Electron negativity. So this word also in chapter 1, there's a table for electron negativity. Carbon and oxygen is 2.5. Carbon is 2.5. Oxygen is 3.5. So CO2 has a polar bonds. You have a polar bonds. So geometry is linear through the Levi structures. Then the polar bonds is cancel. So here, polar bonds means C and O. Between the two elements, C and O have polar bonds. But you combine CO2, the net is 0. Huh? So the molecule is non-polar and do not have dipole-dipole forces. Why dipole-dipole forces don't have? Because it's non-polar. Non-polar, there is no delta positive, delta negative in CO2. Means if you mix CO2 together, they cannot combine. There's no reaction between CO2. Okay? So there are steps. So the one here, the electron negativity, is just to see the C and O, carbon and oxygen. If you combine C and O, is there any reaction or not? If you only look at C and O, yes, there's a polar. But if it's CO2, then you need to look at the structure already. The structure is linear, balanced, so polar cancel, so it becomes molecule is non-polar and do not have dipole-dipole forces. Yeah. Okay, if you draw CH2Cl2, you will get it is a polar, right? So if you look at CH and Cl, electronegativity, this one you look at chapter 1 electronegativity diagram. C is 2.5, H is 2.1, Cl is 3.5. So of course they will have a different dipole if you look at C to C, C to Cl, C to H, and so on. They will have a different, but you combine, you need to draw the Levi structure, right? So the geometry of that we already cover. So if you look at the table, you calculate number of bonds, number of what I call decoupled or lone electron. Then you refer to the table. You get one shape. Geometry is tetrahedron, right? So they will be. So in this molecule, we say that molecule is dipole and has dipole-dipole forces. Again, in test final exam, there will be one question ask you about this one. It won't repeat for CO2, it won't repeat for CH2, Cl2, and CH4. I'll ask you other combination. Again, CH4, you repeat the same. First, you look at electronegativity. You need to explain what kind of bonding they have. So here only C and H. So you explain CH bond are nearly non-polar. Because C and H, they are very, very near, 2.5 and 2.1, very, very near. Okay. But the geometry is tetrahedral. Again, if you forget how to get tetrahedral geometry, go back to chapter 1 lecture material. There's a table. You need to calculate how many bonding and so on. Refer to table, there's a tetrahedral. Any slight priority that bond might have will cancel. So for CH4, it is non-polar and does not have dipole-dipole forces. Once you have non-polar, then no dipole-dipole forces. Yeah? Water is what? Water is non-polar. So water cannot mix with CH4. Okay. So this one another example. Okay. Okay, hydrogen bond. Hydrogen bond, basically, if you have a molecule that have hydrogen in the equation, then basically you have hydrogen bond. As long as hydrogen, you see hydrogen in the compound, right? So for example, I write something on the whiteboard here. See A2AA3H4O6, for example. A means something any element . If you see there's a hydrogen inside, then you have hydrogen bonding. Okay, so polar molecule contain hydrogen atoms, bond directly with fluorine, oxygen, or nitrogen, then you will form hydrogen bond. So this is additional guidelines for you to decide whether it have a hydrogen bond or not. With this, you see H combined with F, H combined with O, H combined with nitrogen. It will form hydrogen bonding. Okay. So there are two ways of determining whether it's a hydrogen bonding. One, you look at the formula of the molecule, got H or not. That's first step number one. If got H, it's not necessarily have hydrogen bonding. Step number two, you look at whether got fluorine or not, whether got oxygen or not, whether got nitrogen or not. If have these three, got F, or oxygen, or nitrogen, then confirm you have hydrogen bond in the molecule. Yeah, so we already covered dispersion, cover dipole, cover hydrogen bond. So how you test whether you have that particular bonding, you look at the formula, you know already. Either it's dispersion, either dipole, or hydrogen bonding. Dipole usually asks about geometry one. You will link to chapter 1 question. Means you can convert into Levi structures, have lines, single bond, double bond, triple bond. Then it's under dipole. Look at the shape. If the shape is irregular or non-linear one, then it's have a polar, okay, or it have a dipole force. So hydrogen bond, again, check whether got hydrogen. Then second step, check whether got oxygen, fluorine, or nitrogen. Okay, something like this lah. So something like this. Okay, yeah. So molecule 1 contain hydrogen. Molecule 2 contain a lone pair. Then here, molecule 1, you have a positive, delta positive and delta negative. Then it will form hydrogen. So hydrogen bond is one type of covalent bonding. When hydrogen atom is covalently bond to an electronegative atoms, in hydrogen, it combined with the atom with delta negative, the share pair of the electron attract to the later one, right? So as a result, hydrogen is slightly positive charge, right? Why positive charge? Because is the negative already go to near to A atoms. Okay. And the electronegative atom is slightly negative charge. This property is known as polarity, and such molecules are called polar molecule. Okay. So this is just explanation on what actually hydrogen bond. Okay. To be easier, you remember this diagram. You draw A, connect to H, you draw delta negative, delta positive, then draw the red dot line. B with the two blue dot, which is have a lone pair, combined to C element. Then you label molecule 1, molecule 2. Then you write these two statements to explain hydrogen bond, which is normally is section A of the question if he asks you to explain what is hydrogen bonding. Okay. Okay, the rest is you read now. The rest you read. Okay. Hydrogen bond is super dipole-dipole force, which is have higher forces compared to the normal dipole-dipole force. Right? It is because of the last difference in electronegativity between hydrogen and the electronegative element. Okay, the rest you read. Basically, in summary, which is the H, you see the H, see the F, see the O, see the N. Then it will explain it is a super dipole-dipole force. This one you read. Okay. Attraction between hydrogen atom and electronegative atoms is called hydrogen bond. So this one is in the short explanation of what is hydrogen bond. Okay. The middle statement, this one is in your calculation when you need to determine whether got hydrogen bond or not. The middle statement is to help you. Check hydrogen, then check got F, O, or N or not. Okay. So this one is illustration. The red dot is the hydrogen bond. Red dot. And again, the orientation is delta negative will align with delta positive side. The red dot is called hydrogen bond. They are not connected, they are just attract like magnet only. They're like Wi-Fi connected. They do not touch, they not physically touch or hold each other. Okay. Just a highlight. Don't confuse bond with chemical bond. Chemical bond is within atom and atom that form molecule. Hydrogen bond is between molecule and molecule. Don't confuse bond and chemical bond and hydrogen bond. Right? Okay, the rest you read. Read. This one also you read. Okay. Substance that have hydrogen bond have higher melting and boiling points based on molar mass also. Okay. This one, hydrogen bond, also based on molar mass. If both have hydrogen, then you calculate the molar mass. Then you can identify which one have higher boiling point. For example, right? It's 2. Okay. So here you can see the molar mass almost same. The structure here, one is balanced, one is non-balanced, right? Boiling point, if it's non-balanced, means it's a polar. Then here you see H, right? H, you look at extra three element, which is the F, O, and N. F, O, N. F, O, and N. So here you have H combined with O, but this one, the C2H, C2H6, H combined with C, which is not FON. So no hydrogen bonding. Okay, so CH3OH have hydrogen bonding, so we have a higher boiling point compared to C2H6. This one you explain the boiling point based on hydrogen bonding. Yeah. So first, dispersion London, you base on a distribution of instantaneous dipole. Dipole, you base on the structures or geometry of that particular molecule. Hydrogen bonding, you look at hydrogen plus FON, right? Rest you read. Okay. This is another illustration. This one you read. Okay. One of these compounds is liquid at room temperature. Which one and why? This will be your final exam kind of question. Very short, but you need to explain a lot. Okay, you are given CHO, you are given CFH3 and H2O2. Okay. So the explanation, if you calculate molar mass, it will be almost similar, right? To calculate the first, for chapter 3, first step, you need to calculate molar mass. Anyhow, you see the question, or this is ask you about intermolecular force. First step, usually you calculate molecular force, molar mass. Then for molar mass, you look at that, almost similar, right? Almost similar. So dispersion force is similar because dispersion force exists in almost all molecules, right? Look at molar mass. If it's similar, then dispersion force is similar. Then 3 compound also polar because they have dipole force. Why? Because you can convert double dot into line, 4 dot into double line, means single bond, double bond, or triple bond. So they have a dipole forces, right? Hydrogen peroxide, however, is the only compound that contain H bond directly to FON. Because this one, H to C, H do not combine with F. It need to go through C. So if you look at hydrogen peroxide, is H directly with O compared to the middle one. That's why we can say that hydrogen bonding, hydrogen peroxide have hydrogen bonding and most likely have the highest boiling point of 3. This one you look at boiling point. It asks you whether it's liquid at room temperature. the state of that particular element at room temperature linked with the boiling point. Yeah? The higher the boiling point, the higher possibility it is in liquid. If it's boiling point very low, it will very easily convert to gases. You release already to the room temperature, it will boil and it will become gases. The question asks you liquid, you combine the state to the boiling point. So if you combine these three, you compare these three, you know which one have the boiling point, and then from there you guess based on the boiling point. Yeah, I try to understand the logic. So this is just based on the argument of the hydrogen bonding, dispersion force, dipole forces. You say state something about the boiling point, then you can make a summary. Which one have the higher possibility it is in certain form? Okay. Okay. This is just a side note lah. Why fluorine methane do not have hydrogen bonding? Because hydrogen was not directly bond with FON. If you see fluorine fluoromethane, the H combined with C and not F. Okay. Okay, this one your homework. And this one also your homework. The one that I don't give you answer is more high, very near to the test kind of standard. Okay. Okay, dipole. This one I go very fast. Ion dipole means it's combined with ionic compound. In this case, as long as it's able to have ion, then it fall into dipole forces. Yeah. Okay. So ion dipole, mixture of ionic compound and polar compound. Ion dipole forces is a mixture of ionic compound and polar compound. So first step, you need to determine whether got polar or not. If non-polar, then 100% it cannot form ion dipole forces already. Okay. Sodium chloride mixed with water, so it will have ion dipole. For example, you take water and NaCl, salt, it will form ionic compound. Okay, so this is the strongest as what we do. I mentioned since the beginning of the class. So this is the ion dipole. It's the strongest among the intermolecular forces. We only look at 4 types: dispersion, dipole, hydrogen bond, and ionic dipole. So ionic dipole, once you can see it is combination between the positive charge or negative charge, ion plus polar molecule, then it will form ion dipole. Okay, so yeah, so this is a summary of the 4 type of the things. I think I give you in the tutorial, right? So this one will help you during your revision. And these are the keyword when we ask you a certain type of forces. And we might ask question from here. We ask you the relative strength. We ask you whether it is, when does it present? And then example here, this is from the question. You get from the question and then you give reason. Then from the reasoning, you can, at the end, you can give me what type of forces that have exist in that particular molecule. Okay. Chapter 3 only link with solid or liquid form. Okay, this is another revision notes. So London dispersion force, dipole-dipole attraction, they are called van der Waals that you learn in SPM. They are van der Waals. Hydrogen bonding is not van der Waals. Hydrogen bonding, they need to have hydrogen combined with FON. Then only can form hydrogen bonding. Okay, then you see non-polar molecule. Yes, London molecule force, dispersion force can form when you have a non-polar molecule. Polar molecule have two types of intermolecular forces, which it can be dispersion or dipole-dipole attraction. Hydrogen bonding can exist in three. So molecule which have contain FON basically. Right? And increasing strength of intermolecular force means the stronger intermolecular force, the higher boiling point you have. This is another diagram. I think I also give you a note. This one I forgot. If no, then you need to refer back to the PowerPoint slides. So these are the, maybe you can say as a rubrics when we check your answer in the exam, or how you use this kind of table to design question. So these are the parameters we use: volatility, solubility, electrical conductivity. Electric conductivity is very easily to see as long as there's an ion. Electricity, when there's an ion inside, you're able to conduct. If no ion, cannot conduct, right? Okay, so this is a question. Okay, we continue 3.7 after the break. No lah, this we continue. Two more slides, we finish. Okay, so this one is basically solid. I think you know lah. This one you read lah. Okay. So read. In your test, or final exam, I want to ask you this one. Okay. Each chapter, I only ask you one question. We have 8 chapters. Okay. Okay. So basically, this table summarizes this section for the crystalline solid. You learn about this one in detail in material science in the degree courses, either in any kind of, either you go to EE or aerospace or mechanical, then this will be inside the material science, right? Okay, covalent bond and so on. Okay, this one you read lah. And this one actually in your chemistry one, whether ionic or covalent bond already covered in chapter 1. This one you read now. Okay, water, this one also your homework, go and read. I won't ask you about water. It's just additional information for this chapter. Okay, so the rest of water, I will just give you the PowerPoint slides. You go and read. Okay, so we have a short break. Now it's 12. We continue 12 to 5, 10 minutes breaks. Okay. Mm.